Today's video is going to cover classification of matter. So we want to be able to classify matter into what it represents. And matter can either, in two broad categories, is either defined as a pure substance or a mixture of two or more pure substances. Okay, so if we just look at what a pure substance can be, we kind of talked about this on a couple pages ago when we were talking about just the properties, physical properties of things, is that if a matter is determined to be a substance, then it is either an element or a compound. So if we look at this first one, an element, these are pure substances that cannot be broken down into simpler substances by any physical or chemical means. Okay? You are not able to change, to break an element down into anything further through a chemical means. Now that means that that the atom is divisible, or you can split the atom, but you cannot do that by a chemical reaction. That is a nuclear reaction, which is completely different. But in normal chemical reactions, you cannot break an element down into anything simpler. Elements are what are found on the periodic table. Some of these examples: hydrogen, oxygen, carbon, silver, and whatever else you might be familiar with from the periodic table. Elements are represented by a symbol of one or two letters. Right? The second letter is always lowercase. We talked about this the other day. First letter is always capitalized. Second one is always lowercase. So you can always, if you're looking at a chemical formula of a compound, you can count up how many capital letters there are. That tells you how many different elements are present. An atom is defined as the smallest particle of an element that retains its identity. For example, helium is and I'm just going to use some chemicals in here. Helium, an atom of helium is the smallest part of an element. You may be familiar with oxygen, right? Oxygen is, whenever you talk about oxygen, elemental oxygen, you're talking about O2, right? That's the gas we breathe in. Oxygen is an element. However, you're not going to see just oxygen atoms floating around. This is referred to as a molecule, but it's still an element. Oxygen is an element because there's only one element present in this particle. Right? Other things like nitrogen gas is N2, chlorine gas is Cl2. Most metals like iron, right, are just individual silver. They're just individual atoms. Okay? Compound is a pure substance that can be separated by chemical means only. And a compound consists of two or more different elements in fixed proportions. And the chemical and physical properties of a compound are always going to be different from those of the elements that form them. Right, just keep in mind, chemical symbols for a compound have two or more capital letters. Okay, chemical formulas show the numbers of atoms of each element that make up a compound. Subscripts following the symbols show how many of each type are in an atom. For example, carbon dioxide, you might be familiar with this, CO2. Right? This formula says you've got one carbon and two oxygens. Table salt, sodium chloride. Right? This formula here, you have one sodium atom, one chlorine atom. Likewise, a simple sugar like glucose that you may recall from biology, C6H12O6, right? This says 6 carbons, 12 hydrogens, 6 oxygens make up one particle of that compound. And a molecule is referred to as the smallest particle of a compound that retains its identity. Now, you may be thinking, well, wait a minute. Didn't you mention up here oxygen, nitrogen, and chlorine? Those would be molecules. Yes, that's correct. Right. Helium is represented as an atom. Iron, silver, those are atoms, but oxygen, nitrogen, chlorine, and there's actually 4 others that will never appear just as a single atom, that they're always paired up with a friend. And oxygen, nitrogen, chlorine are 3 of those. But in O2, N2, and Cl2, that particle is referred to as a molecule. So if you're trying to understand, well, if we can use molecules to describe O2, N2, and Cl2, does that mean that O2, N2, and Cl2 are compounds? No. Right? A compound, it contains 2 or more different elements. Okay, so the easiest way to understand this, or make sense of this perhaps, is that you can say all compounds are molecules, but not all molecules are compounds. Because some molecules will be composed of just these, a single element. So let's talk about pure substances of compounds and elements. Now, mention that matter could be just divided into 2 parts, into pure substances and mixtures. Well, mixtures are just a combination of 2 or more pure substances in which each substance in there retains its individual property. Okay? When you mix 2 things together, the identity of each substance is not changed. Mixtures do not have specific properties. And mixtures can be separated into simpler substances by a physical mean. Okay? What this is basically saying is, like a mixture could be considered like a peanut butter and jelly sandwich. Right? What did you do to make that mixture? Well, you took typically 2 slices of bread and added some peanut butter and added some jelly. And in your peanut butter jelly sandwich, you're noticing, right, the identity of each substance is not changed. You still see the bread, you still see the peanut butter, and you still see the jelly. You've not created a new substance. And I guess you technically would be able to separate those, the bread back into the bread, the jelly maybe, and the peanut butter back into it, itself. Maybe. It's difficult, but right, you haven't created some new compound that can only be broken down by some type of chemical means. Now, once we've determined something's a mixture, then it's either going to be referred to as a heterogeneous mixture or a homogeneous mixture. Okay, and we need to use our knowledge of prefixes. Right? Hopefully you understand what the hetero prefix means. Hetero means different. Homogeneous, or homo as a prefix, means the same. So a heterogeneous mixture is defined as a mixture that does not combine or blend, you could say, smoothly throughout, in which you can still make out the individual substances quite clearly. You can say that they remain distinct. For example of this, like a heterogeneous mixture would be a salad. Right? You've got some lettuce, you may have some other things in the lettuce, like tomatoes or croutons or what have you, and you look at it and it looks different throughout. Like if you had granite countertops, They do not look the same throughout. Seawater, right? Seawater, if you're looking at the surface of seawater, you're going to see some probably, some sea foam, on the water, or just some color variations. Anything that does not look the same throughout visually is not going to be considered a homogeneous mixture. Like your desk at school is not homogeneous. Right? You can see individual things. This paper, even if there was no printing on it, if you look close enough, you're probably going to see some differences across the surface of the paper. Okay, so heterogeneous typically means it is not blended smoothly throughout the things. A homogeneous mixture is something that has a constant composition. And it always consists of a single phase or state. Homogeneous mixtures are often referred to as solutions. And solutions can be any state, right? They can be a homogeneous mixture of solids. The most common example of that would be like a metal alloy. Liquids can also be homogeneous mixture in solutions. That would be like, say, water. Tap water is going to be a homogeneous mixture because it's going to have the same composition throughout. It's not a pure substance because tap water has all sorts of dissolved minerals and other materials in it. And you can have gaseous solutions. So an example of a solid solution would be any type of metal alloy. Liquids, right, would be like tap water, non-carbonated sports drink, like Gatorade or something of that nature. That is a homogeneous. And gases would be the best example for that would be like the air that you breathe. Right? It looks the same throughout, and it has the same composition throughout. Think about it this way: if air was not a homogeneous mixture, that means like the air in your room at home or the air in the classroom at school. There's be pockets where there's oxygen and there's pockets where there isn't. And it'd be kind of easy to tell where those pockets that don't have any oxygen because there might be some passed out students in those areas. Okay? So that's the difference. Heterogeneous mixture, not a common constant combination or mixed, composition throughout. Homogeneous means it is. Raw milk. If you've ever seen, raw milk that came straight from the cow, so to speak, it's heterogeneous because if you let raw milk rest, so to speak, it's going to separate into layers. If you look closely on like a milk carton that you buy at the store, it's probably going to say that the milk has been homogenized. Milk will separate. They process the milk and homogenize it so that it doesn't separate. So you don't have to like shake up your milk before you take it out of the container because people might get a little bit concerned that their milk has gone bad, so to speak. Okay. So we mentioned that mixtures are things that can be separated by physical means. And some of the physical means of separation, techniques that we will use in class when we do labs, the most common one is filtration. And this is just a technique that uses a porous barrier to separate a solid from a liquid. And we're just separating this mixture based on the physical properties. So you may recall, again from the aluminum foil and the copper 2 chloride lab, when you were done with your material, you brought it up to the front lab station and poured it into one of the funnels that had filter paper in there. And what we're doing there, it was separating the substances, separating the solid out from the liquid phase. Okay, and we're using filter paper, which just acted as a porous barrier that allowed the liquid molecules or particles to pass through the filter paper, but the solid particles were not able to. Okay, so that is a common physical means of separation. So is something called distillation. You've probably heard of the term distilled water, right? And that is a separation technique because, as you know, or may not know, our tap water is filled with all sorts of dissolved minerals in it, right? If you have a water softener at home, a water softener is not like making it pure water. It's just swapping out some materials that are considered harder or harsher ions for softer ions, so to speak. But if you wanted to get distilled water, that is basically trying to get pure water. And distillation is just a technique to separate things based on differences in boiling point. Okay? So let's say you wanted to make some distilled water. You would start boiling water, right? Because water is going to boil at a much lower boiling point than anything that's dissolved in it, like any type of salt, any type of ionic compound, any type of what have you. And then you need to collect the gas, the steam that was created, and condense it back into liquid. And then you would have distilled water. And that is what distilled water means, is that it has been boiled and the steam has been captured and condensed back into water. So it is about basically the purest form of water you can obtain. Chromatography, you may have used chromatography paper before, but this is just a means of separating things of a mixture, typically like inks and those sort of things, based on their ability to travel across the surface of another material. And lastly, crystallization just is a different way of separating things based on basically solidification. It's like the opposite of distillation. Okay. Just to kind of put all this together in a visual organizer for those of you who are fans of such things, matter, right, can be broken down into two main groups. A pure substance or a mixture. Once we've broken down into these two main parts, then pure substances can be further broken down or classified as either an element or a compound. Whereas mixtures can either be considered homogeneous or heterogeneous. And once we've gotten to that point, then some examples like elements, like carbon. And I'm just going to use the symbols from the periodic table. Carbon is C. Oxygen, right, O2. Bromine is another one like oxygen that if it's not in a compound, it is going to be paired up with another of itself, like iron, nitrogen, sodium metal, uranium, tungsten. Those all are considered elements. Compounds, right? I'm just going to write formulas for compounds. Like H2O, right? We know that as water. Table salt, sodium chloride, carbon dioxide, N2O, which I believe is nitrous oxide or laughing gas. You notice the key thing here, how many capital letters in the formulas? Right, at least 2. Now, if we're talking about examples of mixtures, things that would be considered homogeneous would be like around your house, like vinegar, bleach, air, that's a common example, like steel. Like steel is a metal alloy of iron and most commonly carbon, but oftentimes with other materials as well, like Windex, so on and so forth. Heterogeneous would be like Italian salad dressing. Right? Those typically contain like a mixture of oil and vinegar. And you notice the oil and the vinegar don't mix well. You've got to shake the bottle up before you use it. And then if you let it sit, it'll separate once again. Like I said, raw milk, that will separate. salad. Chemistry kitty. No, gotta hold off. You are a heterogeneous mixture. Whether if you just are looking at the exterior of your body, your skin and whatnot, you do not look the same throughout. Even if, take a cross section of you, you do not look the same throughout. Most organisms are definitely a heterogeneous mixture of things. That's pretty much it. So if it doesn't look the same throughout, it is heterogeneous. If it does, then it is homogeneous. Uh-oh, kitty. No, don't be stepping on the keyboard. Just dodged a bullet from the chemistry cat. And lastly, just some quick thing about the periodic table. And we'll get into this into much greater detail in the next unit. But the periodic table, right, it is broken out into horizontal rows, which are called periods. And there's 7 of them. And there's then 18 vertical columns, which are called groups or families. And the lanthanized actinized not in a group, which are the bottom 2 rows of the periodic table that are kind of broken out. And like I said, groups are also called families. So that does it for this one.